Hello everyone, today I am going to present our paper entitled Treatment of Chloride Ions and Heavy Metals in Polymer Art for Sustainable Recycling. I am Nguyen Thi Thao and together with my teammates Khanh and Hiep, we will guide you through our presentation. Our presentation considers four main parts. First, the research background. Second, the current status of performing arts management in Vietnam. Third, the treatment methods for removing chloride ions and heavy metals. Finally, the main reason. Now, let's move on to the third part, the introduction. Vietnam is facing increasing municipal solid waste due to rapid urbanization, making waste-to-energy incineration an effective solution for reducing waste volume. However, this process also generates a large amount of potent ash. The main challenge is that potent ash contains high levels of chloride ions and heavy metals. Chloride ions can cause steel reinforcement corrosion, while heavy metals may contaminate soil and water through long-term leaching. Therefore, this study aims to evaluate these challenges and propose suitable treatment methods to support the safe and sustainable recycling of potent ash. Now, let's move on to the current status of waste-to-energy plants and potent ash management in Vietnam. The counterplant was Vietnamese first waste-to-energy facility. It ships 400 tons of municipal solid waste per day using a single red furnace. About 18 to 20% of the waste becomes potent ash, while fly ash accounts for around 4%. Most of the residues are solidified and reused as construction materials. This diagram illustrates the overall waste-to-energy process from waste feeding and conversion to energy recovery and ash collection. Southern is currently the largest waste-to-energy plant in Vietnam with a treatment capacity of 4,000 tons per day. It uses advanced water-level mechanical waste systems to achieve stable and efficient combustion. The first diagram shows the waste incineration process, while the second shows how bottom up is treated and recycled into non-fire bricks. The Statafin plant processes 2,250 tons of waste per day using German Martin mechanical red technology. It generates about 156,000 tons of potent art each year, which is recycled after metal separation into non-fired bricks or concrete pile. This diagram shows the incineration process followed by metal recovery and potent art treatment before producing recycled construction material. The Fusion plant has a capital capacity of 600 tons per day and uses a hydraulically driven stable waste system. The design ensures the stable combustion and efficient air flow for continuous operation. Overall, popping off in Vietnam is still mainly stored or given basic treatment before limited reuse. The biggest challenges are its high chloride content and heavy metal leaching, the lack of technical standards, and the high cost of advanced treatment technologies. To address these challenges, several treatment methods have been developed for reducing chloride ions and stabilizing heavy metals in polymers. The first method is wet treatment method. The second method is mechanical treatment. The third is stabilization, solidification, and finally is carbonation treatment. After reviewing the treatment methods, let's move on to the results. First, let's look at the particle size distribution of bottom earth. Bottom earth accounts for approximately 15 to 25% of original waste mass, as shown in the chart. Around 70% of particles are larger than 3 millimeters, with the largest proportion belonging to particles larger than 5 millimeters. In terms of composition, polymer is highly heterogeneous. It contains glass, ceramics, minerals, and so on. This variability makes judgment and different particle size have different chemical properties. Next, we analyze the chemical composition of polymers. The bar chart shows that calcium oxide and silicon dioxide are the dominant components in all samples. However, together they account for only about 50 to 60% of total composition, which is lower than value typically reported in developed countries. This is mainly because municipal solid waste in Vietnam is not well celebrated as a child. The EDS analysis confirms the presence of major elements such as calcium, oxygen, carbon, silicon, and so on. The pie chart highlights a significantly difference in chloride concentration among the three pies. Control recorded the highest chloride content at about um, 30,000 and 300 million grams per kilogram, while fusion has a lowest value. Although relative concentrations of heavy metal remain within current regulatory limits, their total content is still relatively high. Without proper treatment, they may gradually leach into soil and groundwater, posing long-term um, environmental risks. Based on this finding, several important conclusions can be drawn. First, Vietnam's potash contain relatively high chloride levels because municipal solid waste has a high proportion of food and organic waste. Second, conventional methods such as water washing or Portland cement stabilization can reduce contamination, but they do not provide a long-term solution. Therefore, as studies suggest, biopolymer technology as a more sustainable alternative. The biopolymer matrix can effectively immobilize polychloride ions and heavy metals while reducing carbon dioxide emissions and converting bottom earth into valuable construction materials. In conclusion, Potomac from municipal solid waste incineration, which accounts for about 20% of the input waste, presents significantly environmental challenges because of chloride, ions, and heavy metals. Our results indicate that geopolymerization is a promising solution to safely immobilize these pollutants and transform bottom earth into sustainable green construction materials. Thank you very much for your attention. We would be happy to answer any questions.